I always forget that. We're going to talk about strategies again here. Again, these are the things that should be in your toolkit if you are designing or building or part of the project team for a green or sustainable building. You're not going to be able to do everything on every project, but it's good to be aware of the design choices that you have available to you and then choose appropriately. So we're going to talk about water efficiency. We had this slide last week. Again, buildings exist in a context. One of the things that they exist in the context of are the systems that support the building. And our building will kind of sit at that dividing line between the water supply and the wastewater disposal. And we're going to draw water from a water supply system and discharge some wastewater to the wastewater treatment system. So we're going to be talking about WE water efficiency credit category. WE credits have to do with both indoor water use and outdoor water use. So we will look at both of those things. But first, some definitions, especially for indoor water use. A lot of things are going to be tied to the GPF, or gallons per flush, for a toilet, a water closet, a urinal, or the GPM, or gallons per minute, of a faucet or a sink. In the case of WE, or water efficiency, we're going to be called upon to calculate a baseline. Baseline is typically how much, in this case, how much water would your building use if all the fixtures met the requirements of EPAC. EPAC is the Energy Policy Act of 1992, so the reference material will have this table in there. It says an EPAC water closet or toilet is 1.6 gallons per flush. An EPAC urinal is 1 gallon per flush. So again, you take your occupancy, FTE, is full-time equivalents, and how many people are in the building, and you run the calculations about how much water you would use, indoor water you would use, if all your fixtures were designed according to EPAC. That's the baseline. That makes sense? Again, in the old days, water closets or toilets used to use 3.5 gallons of flush. That was typical. And as you see, we have figured out a way to greatly reduce water requirements for flushing toilets, which is a good thing. Right, so again, we have both credits and prerequisites in the LEED system. Yes. Again, this is 1.6 is as of 1992, many years ago, the last time the government kind of did this stuff systematically. So yes, 1.28, as you see, Susan, will be a much more common GPF for a toilet or water closet. Good question. Again, as I said, LEED has prerequisites and credits. Prerequisites are the things that you must do. So the prerequisite for water efficiency is that you have to get down 20% from the baseline, right? Again, the baseline is if you had EPAC fixtures and occupancy remains the same, right? So that's your starting point. You got to be 20% under just to play the game, right? That's your ticket. You got to punch the ticket before you can go any further. Some other definitions of things that you find in the world of water efficiency. Potable water is water that you can drink. That's drinking water. You may see it referred to as white water, right? Not the white water that you might kayak or raft in, but white water in the sense that it's safe for drinking. Non-potable water is water that's not drinking water quality, but still may be used for plenty of other purposes. Gray water is water that has been, let's just call it gently used, right? Gray water is used water from sinks, showers, tubs, and washing machines. And black water is water that is more than gently used. Water is the wastewater from toilets and urinals. Black water has come into contact with fecal material, right? That's the stuff that you're doing your business on the toilet, right? Fecal matter is a haven for harmful bacteria and disease-causing pathogens, right? So that's not stuff that, we want to make sure that gets discharged to the wastewater system. So from a building code standpoint, anything that has not come into contact with human waste might be, as you see in a minute, will be suitable for potential reuse. So again, we have to think about potable and non-potable water, and gray water and black water. So what are some of the strategies? My little toolkit there, when I remember to stick it on the slide, right? What are some of the strategies? What are some of the things that are going to be in our toolkit? Obviously, for indoor water use reduction, the most obvious thing in our toolkit will be water efficient plumbing fixtures. And Susan has kind of anticipated where this is going to go, right? We're going to go from fixtures from 30 or 40 years ago. Water closets would have been 3.5 gallons to flush to 1.6, and now we are at 1.28. We also in LEED, we have at least the potential of doing gray water recycling. Gray water recycling means we're going to use a gently used non-potable water source for toilet and urinal flushing, right? There's no reason why we have to use fresh water, drinking quality water to flush toilets and urinals with. We have other sources of water potentially that we can use for those purposes. And the other thing that LEED is going to want us to do is to sub-meter, right? We want to track and record water usage, and we want to monitor for leakage. And again, from a maintenance perspective, we want to make sure that all these fancy, efficient fixtures that we put in the building are continuing to perform in the way that we expect them to perform. So let me switch slides here if I can. Where's my sharing screen here? Do I get this to work here? that is a little simple thing that shows what gray water recycling is, or one way of implementing gray water recycling. And let me find my... Right, so we're using non-potable water, gently used water for toilet and urinal flushing. Again, no reason why we necessarily have to use potable water for those purposes, aside from the fact that that's the way. Good question, Susan. Susan asked, do we have to treat that gray water before we use it again? We're going to get in and look at the plumbing code, and hopefully, or at least I'll point you in the right direction of looking at the plumbing code. Yes, you're probably going to have to do something before you use that water again. Right, so nowadays, typically a low flow toilet uses 1.28 gallons of flush, and a lot of toilets are set up with a dual flush mechanism where you flush 0.9 GPF if you are doing number 1 in the toilet, and 1.28 for number 2. Again, we're delving into a delicate topic here, so but that's the nature of this particular business. Yeah, dual flush toilets. You might see those 2 buttons on there. You also have, I should have put it, when I post these slides, I'll put a picture of a dual flushometer that accomplishes the same thing. Right, so in the urinal side, right, guys, you're familiar with this appliance. Ladies, maybe less so, but again, we have the same stuff going on in the urinal side of the equation. On the men's side of the restroom, going from low flow urinals to pint urinals to waterless urinals. And a waterless urinal, there, as the name implies, there's no water being used for the system. But typically, that waterless urinal has some kind of cartridge in there that's going to treat the water going down the drain. That cartridge is going to require maintenance. So again, just like in water closets, manufacturers have been making this stuff more and more efficient. Remember I said that way back when 3.5 gallons per flush was the standard or typical figures for a toilet. If you happen to be doing a existing building project, and I'm using the word China here, right? Not China the country, but China, the piece of porcelain that's the toilet itself. I learned this because, as I mentioned before, in my last job, we did a bunch of EB, existing building projects. We were always looking to do water efficiency projects, but more often than not, if we had existing toilets, 3.5 GPF China, we couldn't really reduce the flow rate because we would have unsatisfactory performance, right? Unsatisfactory performance, right? All the waste wouldn't go down the drain because that China wasn't really designed around the lower flush rates. If you're designing new, if you're putting in a new toilet, you won't have the problem, but you might have that issue if you are retrofitting an existing building or doing a EB O&M project. So you got to think about both. This little thing here is the flush valve or the flushometer, right? Typical in a commercial toilet. Along with those uses of domestic water, there will often be processed water use in a commercial building as well. So what are some of the typical processed water uses? Well, we have heating and air conditioning would be the largest processed water use. The cooling tower. So a cooling tower helps cool the building, rejects heat from the building by evaporating water. That's often a large water use, especially in a warmer climate. You might have makeup water for a boiler system. You might have processed water use for food preparation or dishwashing. You might have processed water use for laundry. Again, those are all areas that we can look at for water conservation, along with the domestic fixtures. And what is a cooling tower? A cooling tower, looks like this box. Typically sits on top of the building. We're going to take warm water from the air conditioning system, and we're going to evaporate some of that water as a means of rejecting heat from the building. That evaporated water needs to be made up for. We have makeup water. So that's often a fairly substantial water use in the building as well. It could be larger than the domestic water use in many parts of the country. So we have to think about that as well. We talked about gray water reuse or gray water recycling. Right? So in the case of water use and recycling, we're trying to match the quality of the water source with the requirements of the task. So what do we need potable water for? We obviously need potable water for drinking, for hand washing, bathing, food preparation, dishwashing, clothes washing, right? All the things that water might come into contact with us. Those are all things that we need to have the higher quality potable water for, right? We don't necessarily need potable water to water the plants. We don't necessarily need potable water for cooling tower makeup. We don't necessarily need potable water for flushing toilets and urinals, right? Those give us some opportunities for water reuse or recycling. So for gray water recycling, we might potentially use gray water for toilet and urinal flushing. We might use gray water for outdoor irrigation. Rainwater recycling, right? Rainwater recycling is what we're doing at Triton. But we could use rainwater for toilet and urinal flushing. We could use rainwater from our cistern for outdoor irrigation. We could potentially use rainwater for cooling tower makeup. Again, looking at the water quality and the requirements of the task to see if those some of those opportunities exist in our building or in our design. When I've run slightly different versions of this class, I've talked about building codes. Oftentimes, building codes are what are called the I codes, the International Building Code, the IBC, or the IRC, the International Residential Code. There's also an International Plumbing Code, right? The building code will tell you, the plumbing code will tell you what you can and can't do, right? Building codes often say, thou shall do this, right? You have to do this. So sorry, this will be small text, Susan. I'll see if I can get a bigger version of this to send to you. But in the International Plumbing Code, I found a section there about on-site non-potable water reuse systems. So in the fine print there, it says what sources are allowed and what sources are prohibited, and it's generally going to follow what I said before, right? We can recover water from sinks and showers and things of that nature. Obviously, have to send the water from the toilets and the urinals directly to the sanitary sewer. But the International Plumbing Code will say exactly how this needs to be done. And I have to admit, when I was making these slides up the other day, I didn't find that much good information on gray water recycling. In the pre-COVID days, this class used to take a tour of a house in Oak Park where the homeowners have done lots and lots of things. They were one of the first, or maybe the first, residents in the state to do gray water recycling. So it was really, really easy to explain how it all worked when we stood around and looked at the tank in their basement it's a little bit harder for me to explain on slides when you're all virtual. So that's why I tried to find that little clip that I just showed a little bit ago. One thing we have to do if we're going to have systems like this, where we are piping around non-potable water, is we have to make sure that people don't get mixed up and connect something to the wrong kind of water. So purple has become kind of the standard color for non-potable water systems. So again, at the house we would have seen in Oak Park, had there not been COVID, we would have seen purple pipes coming out of their gray water system being plumbed back upstairs to flush the toilets. So again, purple pipes, non-potable water. So again, we talked about WE, or water efficiency, having strategies for both indoor water use and outdoor water use. I'm watching the clock here. We may go a couple minutes over. What are some of the things we're going to do outside the building? Outdoor water use. Obviously, we want to look at using native or adapted plants for landscaping. I use plants that can tolerate less amount of water, right, as opposed to having our building or our campus surrounded by turf grass. We could do xeriscaping. Xeriscaping is a design practice of designing landscapes to reduce or eliminate the need for irrigation. I have a slide about that here in a second. We can use high efficiency irrigation systems. Drip irrigation is a high efficiency irrigation system. So rather than having sprinklers just spraying water willy-nilly all over the place, or oftentimes spraying water on the parking lot or on your car, we're going to deliver that water, as the name implies, drip by drip, hopefully as close to the roots of the plant as possible. The other irrigation strategy is actually controls, ET controls. That's our same evapotranspiration. So an irrigation system with ET controls is going to try to predict how much ET has taken place. In other words, how much water has the plant lost through evaporation or transpiration, and make up just that amount of water. So again, on a hot day, hot sunny day, there'll be more irrigation. On a day when it's cooler or more humid, there might be less irrigation, right? We're trying to save water by having a smarter irrigation system. Again, an outdoor water use strategy, just like at Triton, use non-potable water for irrigation. Again, at Triton, water from the parking lots is stored in the cisterns and pumped out of the cisterns and used for landscape irrigation. And again, in LEED world, we're also going to do sub-metering. Right? We're going to track consumption and make sure there's no leakage, make sure that our consumption is being maintained over time. Here's a slide on xeriscaping. What does xeriscaping mean? So it has to do with sound landscape planning, right? We have to plan and design. We might need a landscape architect to do our xeriscaping plan. We want to limit that turf grass. I think somebody was talking about that before the break. Reduce the amount of lawn. Use water efficient plants, right? Native or adapted species. And then efficient irrigation systems. Sorry. Mulches and soil amendments, along with appropriate maintenance, right? That's xeriscaping. One thing that is becoming more common in other parts of the country, we don't see it here yet, but sorry, especially in Southern California. I think this one sign here that I found on the web is from Tucson, Arizona, right? in some of these areas that are already experiencing water stress, they're taking reclaimed or recycled water, right? They're taking water from the wastewater treatment plant and then piping it back, through purple pipes. There's a purple fire hydrant, right? They're bringing their water back and using some of that reclaimed or recycled water for, things like watering the golf course, landscape irrigation, et cetera, right? And reused in applications such as irrigation and industrial processes. Right. The wastewater treatment system typically has a three-step process: primary, secondary, and tertiary treatment. In the case of our area here, in the case of Chicago, the treated wastewater from Stickney, I'm pretty sure that it's a three-step or a tertiary system. In the case of Stickney, right, that water is discharged back into the sanitary and ship canal. But in some other parts of the country, say in Southern California, or as you saw in that sign, Tucson, right, that some of that wastewater that's been subjected to tertiary treatment may be, piped around and used for other uses. Again, sorry, a lot of slides here, a lot of words on the slide. Right, in the case of our area, right, we're putting our tertiary treated wastewater into the sanitary and ship canal. Somebody downstream might be drawing that water. If you're in Peoria, you might be taking water out of the Illinois River. So you might be reusing the water that we as Chicago put into the sanitary and ship canal. That would be indirect potable water reuse. We haven't yet got around, at least in this country, to direct potable water use, which would mean that we would take treated water from the wastewater treatment plant and put it right into the supply system. We haven't gotten there yet, but we may be forced to do so with continued drought and water stress. Right, here's our scorecard. Again, whoops, sorry, I should have changed that from SS to WE. Was working on this yesterday. Again, there's our scorecard for B, D, and C with water efficiency highlighted. We have some prerequisites. We talked about the indoor water use reduction prerequisite, right? You have to be 20% under EPACT. And then credits for outdoor and indoor water use, cooling tower water use, and water metering. Here is, again, I should say WE there and not SS. I'll fix some of these little typos here before I put them up. Again, here's your operations and maintenance. Same sort of ideas, but focusing on things that you would do to maintain this performance over the life of the building. Just an example, what is that prerequisite must do? Outdoor water use reduction. Again, oftentimes in LEED world, you'll have options. Option 1, option 2. I'd show that the landscape does not require a permanent irrigation system beyond a maximum 2-year establishment period, right? A lot of times with native and adapted plants, you have to get those plants established. And once they're established, once they've sunk down those deep roots, you don't necessarily have to water them anymore. Or you might have option 2 would be reducing. It would be a calculated reduction. Okay, well, sorry, we've gone a few minutes over. I always try my best to get you out of here at the appointed hour or thereabouts. Any questions? Actually, I'm gonna figure out how to do that polling thing here. So be prepared. I'm gonna ask some random questions just to see who's paying attention and who's multitasking, who's watching a movie on their phone or something like that and not paying attention to me. So I'll figure out how to do that for next week. So if you could look through the questions for water efficiency that are posted on Blackboard, please work through the WE questions, the water efficiency questions. If you haven't, please go through those. Please go through the sustainable sites questions as well, and we'll go through the answers to those questions next week, and we will also hopefully be watching presentations from many of you, and we'll see how we make all that stuff go. Any other questions, folks? You're good to go, Matthew. Thank you very much. Brian, if you're still here, please stand by. The rest of you, I think you're good to go, and we will be talking to you again next week. Thank you very much for good class. Yes, good night, Jasmine. Chloe, good night. Are you still there, Brian? If so, can you unmute yourself? Looks like you got a...
Yes.
I emailed you a couple suggestions for books. If you want to take a look at those and just pick one of them, or we can talk them. I just picked out a couple things that I was aware of that I thought might be interesting to you as well. I think biomimicry, if you're an architect, that's a book that talks about how designers can look at the natural world and find solutions to problems in the natural world. I think that's a pretty interesting book. So if you want to look at those and pick one of those, I think you would be, any of those would be a good choice. I was concerned the one that you sent me before is really a design book, not necessarily about green or sustainable design. So I'd like to get you a little more focused on green or sustainable design. The last one I sent, Walkable City, I'm not familiar with that one, but it looked interesting. I think that's going to be, a lot about stuff we talked about a couple weeks ago with density and walkability. But if you want to maybe pick from one of those, and any of those books would be fine with me.
Okay, so I'll just go look over the list and then I'll just email you like which one I'll choose.
Okay, yeah, and it may boil down to which one you can find at the library or which one you can have the Amazon truck deliver the fastest, right? Where time is getting a little short here, but yes, take a look and pick one of those.
Okay.
Okay, well, sounds great, Brian. Thanks for hanging on, and send me a note if you have any other questions or when you figure out what you want to do.
Okay, thank you. Good night.
Okay, good night. Thanks a lot.